In the previous video, we saw how, depending on the choice of the depth of the decision tree, our model would either be very simple or it would end up being complex, and in such a case might end up capturing the noise and thus overfitting. So the choice of hyperparameter had influenced how the model had performed, and today we are going to look at that in the example of k nearest neighbors. So here in the setup, we have 8 points with 4 of them being in blue color and 4 of them being in green color. And these are nothing but the labels, or it is also called as class. So these 4 blue points have a class or label of +1, whereas these 4 have a label of -1. And now we have this particular test point for whom we want to predict the label. So if you recollect, the first step we do is we find the distance of the point from every other point. So here in this table, we have written the original 8 points, their labels, and finally the distance of these 8 points from the test point, that is this particular point for whom we want to predict the label. So now, depending on the value of k, we then take the majority label of the nearest neighbors and assign that label for this test point. So if we take the case of k equal to 3, we have to take the 3 closest points to this. So from this table, we see that there are actually 4 points all with a distance of 1, but we can take any of these 3, and in this example, we have taken x1, x2 and x3, and all 3 of them have a label of +1, and therefore the majority being +1, the same label is assigned to xt, that is our test point. Now if we take the case of k equal to 6, we now are looking at the 6 closest neighbors, and there are still 4 points with +1 and 2 with -1, therefore the majority remains to be +1, so this test point is once again assigned a label of +1. However, if we go to k equal to 8, that is, if we look at all the points in the data set, this time we have 4 blue points and 4 green points, and we cannot say concretely what the label for this test point should be. So based on general understanding, we see that this test point seems to be in between all these other blue points, so we might feel that the label should be +1. But in having taken k equal to 8, we are now in a situation where we cannot clearly say that the label for this should be +1. Now if you look at another example where we take a different point, 4, 2 this time, once again we have taken down the distance of this new point from every other point, and we take k equal to 1 this time. So in taking k equal to 1, we could have chosen any of these 4 points, that is x4, x5, x7 or x8. And in this example, if we choose x4, we see that we have a problem that this time the label would be +1, though it seems like it is closer to points with the label -1. If I increase k to 5, we see that this time we capture a few more neighbors, and this time the majority ends up being -1, and our test point would have gotten the label -1. So from this, we clearly understand that the performance of our model is going to depend on the choice of hyperparameter. So how do we decide on what should be the value of hyperparameter? That is, what value would give us a good performance. So in practice, what happens is that we have these two separate sections called as training data, which we will use to train our model. And once we have built our model, we will test its performance using test data. So this is similar to a setup where in a classroom, a teacher might teach you a new concept and solve numericals in class. But later on, when you take an exam in the subject, you are going to use those underlying concepts that you have learnt in class to see some other numericals that you might not have seen before. So in this case, if we relate it to our example, this time we are going to learn our model, and once we are built the model, we are going to test it on this unseen data. However, we came with this dilemma that the different values of k are impacting the performance of the model. So how do we know what value of k is good before we actually try it on the test data? So for this, we can divide our training data into two parts, one for training the model and the other for as a mini sort of test that we do. This might be similar to the mock exam that you write before you actually write your final exam. Alternatively, this can also be thought of as the examples that you might see in your textbook, wherein you're trying to use the concepts you have learned in your class to solve those textbook problems. But since you have the solution, you will know that whenever you are making a mistake. So with this sort of setup, in our case of this model building problem, we might try out different models with different values of k, check their performance on a small portion of this training data, and then the model that performs the best, we can finally use it on our test data. So with this, we will know what might be a good value of k for our model, that is hyperparameter in general, for the model that we have built. So with this, in the subsequent videos, we will now actually go on and see some demos of these models using Orange. Thank you.